All right, this question says, find the area of the region common to the two polar curves r is equal to negative cosine theta and r is equal to 2 minus 2 cosine theta. All right, so if I'm thinking about this, okay, this would be the area of that blue graph. Hopefully by now we understand that that's going to be 2 minus 2 cosine theta. And the black graph is this whole circle defined to be negative 6 cosine theta. And what I'm trying to do is find what is the region they have in common. So it would be this weird little shape in the middle. Okay, so on this one, I've got to think, okay, I've got to integrate the area of some sectors. But what thetas do I start with? I know I've got this formula, A is equal to 1/2, the integral from alpha to beta, the radius squared d theta. Okay, but where do I start? And do I use symmetry? Which function is giving my radius? All questions we got to kind of figure out together. So I'm going to use some symmetry on this one. I'm going to find out what this is. And whatever I get, I'll double it. All right, so next thing, let's just plug in some numbers. R is equal to negative 6 cosine theta. Okay, if theta is equal to 0, cosine of 0 is 1, and 1 times negative 6 is negative 6. So if theta is 0, okay, the theta being 0 is over here, but the radius being negative means I put my dot way over there. So that's when radius is 0. Okay, what about when theta is 0? What about when I get pi over 4? Or pi over 6? Let's do pi over 6. All right, cosine of pi over 6 is root 3 over 2 times negative 6. I get negative 5.29. So theta is pi over 6, and I get the point negative 5 point something. So it's over here. So the way this graph is going, it's doing this, right? All right, so I obviously don't start at theta is equal to 0. I don't start when theta is equal to pi over 6. I got to find out what is the theta right there. And then as I'm going this way, as I'm finding my radiuses, the black one's the first one. So it's at negative 6 cosine theta. If theta is pi over 2, which is what I think we're going to start at, cosine of pi over 2 is 0 times 6, so it's 0. So it's at this point here. And then as I go on, if I wanted to find like, I don't know, pi over 2 pi over 3, it's going to be kind of tricky because it's actually going to be where this intersects. But I know at this point, it started over here and it's going around at 0, it's here. So as theta goes past pi over 2, it's going to be forming that way. And that's just from like practice and taking time graphing these things. All right, so we got to find this intersection point. Because if I really zoom in, I'm getting my thetas, using my theta for theta of pi over 2, I get radius 0, and then as I go on, I'm getting my radius from that negative 6 cosine theta function. Then right there is where they intersect at some theta, and then I start getting my radius from the blue function. And it looks like I'll keep going until it stops at theta is equal to pi. Then I'll integrate those two things, I'll double it, and that should be my area. Okay, question now is I got to find that theta where these two things intersect. Okay, where those intersect is when the r is the same number. So what I'm going to do is I'm going to set these equal to each other. So I get negative 6 cosine theta. This is to find the intersection theta equal to 2 minus 2 cosine theta. Okay, so I notice if I add 6 cosine to both sides, I get 2 plus 4 cosine theta. Subtract 2, divide by 4. So I get cosine theta is equal to negative 1/2. So you got to think on that unit circle, where is theta, where's cosine negative 1/2? That's when theta is equal to 2 pi over 3 and when theta is 4 pi over 3. So that's going to be this point and this point. So there's going to be a couple ways we can do this. I'm going to do the symmetry way first. But knowing that this theta right here, that theta is 2 pi over 3, then it's going to break up my two integrals. So I think I'm ready to go. So I'm going to set up an equation. It's going to be the area is equal to, now I'm going to wind up doubling this. So I'm going to say 2 times whatever I get, because I'm using symmetry. It's going to be 1/2 the integral from pi over 2 to 2 pi over 3. And I got my radius from the black function, which was -6 cosine theta, that's my radius, square it, d theta, and add that to 1/2 integral, starting at 2 pi over 3 to pi. It's going to give that little yellow area. And my radius there was the 2 minus 2 cosine theta squared d theta. Plug that all into the calculator and we get 15.708. Okay, an alternate way to do this one is to not use symmetry and to just go around the whole thing. So I'm going to go around, let's see if I can erase this. If you're one of those people who like to know one way and not know anything else, then because it messes you up, then just, you're done. We did it. But this is just trying to build some intuition. So if I'm doing this, I know right here is where theta is pi over 2. So I get my radius from the black function there. Then I get my radiuses from the blue function, and I'm going to add up all these sectors, an infinite amount of them. And I'm going to keep going past pi all the way to when theta is 4 pi over 3. Then I continue up from 4 pi over 3 back to 3 pi over 2 using the black function to get my radius. So another way to write it would be 1/2 integral from pi over 2 to 2 pi over 3 using that -6 cosine theta radius square d theta plus 1/2 the integral from 2 pi over 3 to 4 pi over 3 using the other blue radius function, so 2 minus 2 cosine theta square d theta. Then add, picking back up from 4 pi over 3 to 3 pi over 2 using the -6 cosine theta as our radius function, d theta. That would give you the same thing. All right, again, hope this video helped. If you need to rewatch it till it makes sense, rewatch it. But thank you for watching. Bye.